This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and my guest today is Dr. Dov Zazkis, who's a postdoctoral researcher in the Proof Comprehension Research Group at Rutgers University, and who's soon going to be joining the faculty at Oklahoma State University, so congratulations on that.
Thanks for having me.
So we're going to be talking about Dov's article, which was recently published in the Journal of Mathematical Behavior, Volume 35. It's currently available online, and the print is coming soon, I know. But the article is entitled Proof Scripts as a Lens for Exploring Students' Understanding of Odd and Even Functions. Before we get to the article, though, I always like with everybody to start out by just backing up to graduate school. So tell us a little bit about your graduate school experience and who you worked with there.
I worked with Chris Rasmussen at the joint program run by San Diego State and the University of California, San Diego. I did my dissertation around calculus, specifically how students move between representations such as analytic representations and visual representations, and I also talked about sort of moving in between physics contexts as well as those. So that's what my dissertation's about. While you were there, you also took on a kind of a side project of your own initiatives, and then that led to this article. Yeah, that's where this article came from. I always sort of try and seek outside of work and to keep myself interested. I'm one of those people that has to bounce between multiple projects, so this kind of emerged as a side project. I actually finished writing it while I was still working on my dissertation, but it's very disjoint from it, and it sort of led into other work that's still kind of not my major thrust, but as long as it leads to interesting things. Yeah, and there's derivatives in here, so you still have a little bit of a calculus, kind of, a higher level mathematics connection. Yeah. This article in the Journal of Mathematical Behavior, you focus on proof scripts. So first of all, I just wanted to start by having you tell us a little bit about what you mean by proof scripts. So to understand proof scripts, it's kind of important to understand where they came from. My mother is a math ed researcher, and she developed these things called lesson plays. There's a book she recently published on them last year with Peter Lillendale and Natalie Sinclair, and those evolved as ways of getting at pre-service teachers thinking about pedagogy and actually getting them to imagine what a teacher-student interaction looks like. So basically they write out an actual script for an imagined dialogue where there would be a teacher character and possibly multiple student characters, and this got at their images of what the pedagogy was like. But in doing this in a math education context, you get a really interesting lens into the actual mathematical thinking that the teacher has. And so the proof script is essentially the same basic idea. It's the same data collection method, except when we're analyzing it, we're trying to concentrate mainly on the mathematics rather than the pedagogy. Okay. In seeing how someone imagines an interaction around a mathematical phenomena, in this case, proof, we get a sense of what their images of that are, what sort of hiccups they have. And so it sort of evolved out of that. And the name change is solely to signify that we're sort of focusing the analysis in a different direction. Okay. And so it's not pre-service teachers, writing a script for what's going to later become a formal proof. It's pre-service teachers writing a sort of a imagined dialogue between teacher and student. But the teacher and student happen to be working on, can we reason our way to some truth or false of some claim? Right. So this is sort of re-envisioning. In the case here, it's re-envisioning a proof as more of a kind of dialogue between two people, where it may be unclear what the particular pieces are, and one person asks and get things clarified, and one person may ask questions to see whether the other understands. So it gets at more nuts and bolts than a written proof could get at because of the medium. Mm-hmm. And it might naturally sort of include false starts to the proof, like, we tried this out, but then the teacher character maybe asks, well, what about this? Have you thought of this? And then they realize, we have to actually fix that part of the argument.
And so that those wouldn't be included in a formal written proof, but you can kind of work them into the dialogue to add some drama to the dialogue.
Absolutely, and we can, and it's sort of encouraged to make it not be sort of a straightforward go ahead. And there's lessons learned from doing a couple of these over, where you want to sort of put barriers in place for the students so they don't just write a student character asking a bunch of questions to clarify definitions, and then the proof bit just sort of gets written through. Like, oh, so if you understand all the definitions, the proof is clear. Well, that's not the case. So you can sort of write that into the assignment itself and actually make sure there's some kind of substantive back and forth about the content involved in the dialogue. This generally the pre-service teacher is the person that's writing these. So you get at their ideas of what a proof is.
Right. Do you have them write the proof scripts like during class? Is this how you did it? Or did you do it as
This
a
is
assignment?
generally a take-home assignment.
Okay.
And the great thing about this is it's really cheap data to get. You can have 4 or 5 such assignments in a class, and they can revolve around various proofs, various mathematical ideas. And if you've gotten the correct IRB approval, any of those is free data, and you can say, hey, that assignment I found particularly interesting. There were some mathematical hiccups that revealed some things that I don't think were particularly in the literature, and you can sort of turn one of those into a research article. So that's kind of what happened here.
Right. So you had pre-service teachers writing these proof scripts about different pieces of content or different claims that were being proved. In the article, you focus on derivatives and then odd and even functions. So what was it that led you to have those kind of be the focus of the article?
Essentially, they kind of lined up with my existing interests. It's a lot of the things I'm interested in my dissertation, because it was surrounding a calculus context. And so there was just this proof that's actually taken from Manya Raman's dissertation that I really like. It gets at a lot of kind of deep ideas. It has a fairly elegant informal argument, and so it was just presented as such. Here's something that in her dissertation was this informal argument, and because it's relatively informal, there's a lot of room for discussing what the actual ideas are that are going on. And the proof in particular is a proof that the derivative of an even function is odd, and there's some intuitions behind it in terms of what's happening with tangent lines and how they get reflected across, and that reflection is part of what it means to be an even function.
So like a tangent line, like imagine in quadrant 1, a tangent line that's going in some direction. If it's an even function, that means you're basically going to just reflect and have the opposite slope tangent line on the quadrant 2.
Yes, and the informal argument of it, and there is a picture that goes along with it that shows that on a particular function that looks a lot like x squared, but isn't labeled as such. And students can actually reason about what's going on, and actually you get at their understanding of derivative out of that. You get their understanding of odd and even function.
And do they think of odd and even function very generally, or do they only think of it as polynomials or something?
They generally kind of focus in on a lot of very familiar cases, and they're actually not polynomial cases. In most of the time, they're monomial cases. Basically, x squared, x to the 4th are the only examples that students generate. There might be the occasional cosine in there, but generally students have a very narrow image of, at least the students in this study have a very narrow field of examples they work with. Their example spaces are quite limited, and it becomes very apparent when you have them write these scripts. In fact, some of them actually redefine what odd and even are in the course of a conversation. Like let's say if there's a conversation between a teacher and a student, the teacher character would say something along the lines of, hey, why don't we call these things that have x to an even power even functions, which is not what the definition is, but the second you make that move that move exists as a teacher character, it says a lot about the person that wrote the script. It says that they view that as sort of a pseudo definition of even,
especially if it stops there, and if it later doesn't expand the definition.
Right, and that was very often the case. The examples were limited to a particular field. It reveals a lot about their conceptions of odd and even functions, which are important subjects. They come up a lot in later mathematics, Fourier analysis. So
Yeah.
it's kind of concerning that the pre-service teachers don't understand these concepts as well as we like, but that's generally true about a lot of mathematics.
Right, and as we can already tell, these proof scripts really do reveal some things and really allow you as a researcher to dig into their understandings.
And they're fun to read through. Is part it is probably as much of the motivation for doing the research as anything else. It's just enjoyable data to go through. It's not like slogging through hours of video of students working on things. They're, at least for me at the moment, still kind of a novel way of getting at people's understanding of mathematics. And so I think that's part of what I enjoy about them. It's probably one of the funnest assignments. I mean, even as something you're handing to students that you're going to grade to read. It just happens to be something you can also get research out of.
Right. I want to ask, before we go further, just because people might be curious about the prospective secondary teachers that you're talking about. So you had them writing these proof scripts, but just tell us a little bit about that population.
They're generally people that want to end up being math teachers. A lot of them have struggled through a science or a math degree. They're fairly far along. They're all in a professional program and have already finished their degree, so they're doing a 1-year program to get a teaching certification.
So their degree's complete, and they're just kind of finishing up certification.
So they should assumingly be fairly bright and semi-well off mathematically, but there's always holes in people's math knowledge.
Yeah, it's especially if you start digging into the conceptual side of things, yeah. And then it was 14 that were reported on in this article.
Yes.
Yeah, okay. So after you collected their proof scripts and you said you had kind of fun going through the data and reading it, but what was kind of the analytic approach that you took to make sense of it?
So of course you sort of, because it's a tangible assignment that students need handed back to them, you sort of take a first pass through them and evaluate them as sort of assignment objects, so you sort of get a good sense of what the data set looks like and whether it's actually worthwhile to explore sort of deeper and turn into some kind of a research piece rather than just a fun assignment to give to students. I mean, if I encourage any researcher to just try this if you teach pre-service teachers in any way, at least as an enjoyable thing for them to do, or at least more enjoyable than usual. And after that first pass, you sort of get a sense of what's where, and then you start clumping things together that are similar, and then actually going through the nitty-gritty of comparing across and actually saying, hey, did these clump actually occur anywhere else, and getting a better sense for how often something you noticed here actually occurred in the data set. But of course, this is a relatively new tool, so there's probably a lot of work to be done in terms of systematizing how to actually analyze this sort of new type of data that not a lot of people are using. So if other people want to try it, I encourage them to let me know how they do it.
Yeah, sure. My guest is Dov Zazkis, who's a postdoctoral researcher at Rutgers, but soon to be on faculty at Oklahoma State University. We're talking about his article in JMB, which is entitled Proof Scripts as a Lens for Exploring Students' Understanding of Odd and Even Functions. So some of the ways that you did kind of cluster the data and make sense of it, you talked about levels of abstraction that happened, and then you also talked about the example space, which you hinted at already a little bit before, but I wanted to just ask you about what you saw in those clusters, maybe starting with abstraction, what was going on there.
So in general, when people talk about a mathematical object, they don't talk about it in its sort of full abstract sense, especially when there's sort of a teacher-student interaction being represented in a dialogue here. So it's necessary for people to sort of communicate without this sort of the full definition, or they'll sort of pick a sub piece of it or work with a more narrow bit, and so the actual how they reduce to something less abstract says a lot about how they interact with the concept itself. So I used Hazan or Hazen if you're in the U.S. Is reducing abstraction framework, which sort of helps chronicle how that reduction of abstraction happens. So that was very helpful in terms of seeing all the ways that students actually express these concepts. They're not mathematicians. They don't work with the full definition. They'll sometimes just exemplify with a specific case, which is an example of that. So that was very helpful. And the other thing you asked about was the example spaces, which was sort of also a very salient feature, which is the actual examples they used tended to be monomials or very familiar functions, and they often didn't see that this was a very general thing that existed for all even functions, which is an interesting thing to know about how students think about even functions. And the other thing that was fairly interesting is how they actually interacted with the diagram. And a lot of them even assumed that it was just a positive monomial and dealt with something that looks very parabola-like, and assumed that the picture they were given is very much what all even functions would look like, which is blaringly false. But it's sort of what became apparent in their writing of a script.
So the use of the diagram, so they would, when they wrote the proof script, they would actually draw a diagram or a graph to go, and would they say like the characters are actually referring to this diagram and using that, and that's where
there
the
was a diagram included in the actual problem, and they kept on referring back to that as sort of not an instance, but like the instance of an even function.
Okay. So the way in which they referred to or used that throughout the dialogue is kind of telling about whether they recognized it was there to show one example to kind of kick things off, or whether they just kind of stayed stuck to that example rather than generalizing beyond it.
They weren't sort of able to realize what attributes of that diagram were general and what were specific to a specific even function that was given, which is very interesting.
Yeah, and now that's kind of speaking in general, like across your 14, that was generally the case. Were there some that were kind of exceptions to that?
There were some that were exceptions to that. There were some that knew that there were sort of periodic functions that this would work for, but the major, more than half of them, I'm sure the specific numbers in the paper, don't have nearly as rich a conception of what it means to be an even function as we would like. And even the ones that do have sort of an example space that exists beyond a monomial function, it's still fairly limited to sort of just the classic examples. I didn't get you obviously don't have room in this type of data to ask follow-up questions, but I did get a sense that...
Yeah, I think the thing that I remember being kind of telling was, if in the proof script the teacher character kind of like says, here's like a summary statement of what we've figured out, and if their summary statement is actually still pretty limited or only like a partial argument, the fact that your pre-service teacher is writing that as if that's like the end of the dialogue and that's what the teacher would say to wrap everything up seems to give evidence that the pre-service teacher themselves doesn't realize that it actually needs to go a little more general than that.
Absolutely. And we give them leeway if they want to have it. Obviously teachers do make mistakes, and if they want to have a teacher make a mistake that gets later corrected, they're fully able to do that.
Right.
But they're told when they're creating the assignment that if the teacher makes a mistake and the student doesn't correct it, and it sort of ends up with that being sort of a salient feature of the script they write, that's an indication from a marker's point of view that something went wrong.
Right. Yeah. Now you also, you're dealing with a claim about even functions, but it's the derivative of even functions, so there's also some content related to derivatives. And actually a previous guest on the podcast, Junyoung Park, episode 1206, she talked about some difficulties that students have between derivative values at specific points and then the derivative function as a kind of overall function. And that just came to mind when you were, in your paper, were dealing with the understanding of derivative. So I was wondering what you saw from the proof scripts in terms of your prospective teachers' understanding of derivative.
In the same way, it was quite limited in terms of being able to make the transition between those two entities. And actually, I'm a big fan of her work. I wonder if he's listening.
Well, it's funny. We're recording this right now at the PMA conference in Vancouver, and I just ran into Junyoung on our way over. So
we'll go find,
she's here.
Go find her and have a beer.
But yeah, so what did you see that kind of maybe corroborated her work?
Sort of the same sort of reliance on this image of, because the proof itself involved using specific point derivatives, and many students weren't able to express anything past that. I mean, in order for the proof to work, the specific points chosen in the diagram aren't necessarily stationary. The diagram just showed that it exists for like some arbitrary points, but students weren't necessarily able to see what's supposed to be general about that. And that's very consistent with a lot of findings in terms of research on derivatives. So it's nice that when you see the same things other people have seen in your own work,
right?
Because when that's not the case, you either question other people's work,
or you got a little more work to do on yours.
You got a little bit more work in terms of how you designed your study.
Yeah.
So that was kind of more a reassuring thing that was in the data.
Yeah.
It's also, I think my main motivation for actually including that bit of information in the paper is that it sort of shows that this new type of data is able to confirm other phenomena that people have found using other methods.
Yeah.
So it's not sort of...
Gives a little trustworthiness to the whole approach, the methodological.
Right.
Yeah.
Right, because it's still, I mean, it's not something that, since it's something relatively new, I'm still in the process of figuring out how to work with it. Mm-hmm. And I think anyone trying it would still sort of be participating in that process. And I think that's part of what excites me about it. Yeah. It's not the same type of analysis I was doing for an entire very long dissertation, which is part of why I think I have a lot of fun with it.
Right, yeah. A little respite, and it sounds like a pretty engaging type of analysis to do, and just in terms of the
it's
fun of getting into the data.
It's very pleasurable to read. You don't have to transcribe it because the students are handing you something written.
Boy, I hear you.
It's sort of ready-made data that you can just pick up and start analyzing using whatever tools you like to analyze.
Yeah.
And it's not unlike analyzing other types of transcripts, except you're sort of keeping in mind that this is being created by one person and isn't a two-person dialogue. Mm-hmm.
So I want to ask you about some takeaways from the article, but it sounds like one of the takeaways maybe is about the method of using proof scripts. Do you have any final words you'd want to say on that?
I would just encourage people to try this out in their own classrooms just as a interesting assignment, and if you get some interesting data out of it, I encourage you to write a paper, and if you're having trouble analyzing it, feel free to send me an email, and maybe we can give each other advice. And
it's the kind of thing that could work, would you say it could work in content across the spectrum, like middle school content, high school content?
I know that it definitely works for, it's been done with pre-service elementary teachers and pre-service secondary teachers at this stage, and it works quite well. I'm hoping to experiment with getting math majors to actually write these scripts, which may be a little bit harder to sell, but I think there is a lot of potential to get at students' mathematical ideas, even though there may be a little bit more selling of, yes, this is your assignment in this class. Right. This is something we are going to complete, and this is the reasons for it. But I think even math majors do a lot of interaction with each other and explaining mathematics to each other, so I think getting them to think about that has potential not only for me as a research tool, but has the assignment is both useful for them to do and useful for me to analyze.
Right.
So hopefully this coming year I have a couple of calculus classes. We'll see how this kind of data works out with them.
Right. Speaking of other populations, I'd be curious about the proof script task and data collection with practicing teachers, because practicing teachers, they might actually draw on actual experiences interacting with students, where it's like, I'm the teacher and these are real students that I've interacted with about this content. So then if you ask them to write this imagined dialogue or imagined transcript, they might be kind of drawing on real experiences plus some kind of, imagining how they think it could go.
And there's some, then the dialogue doesn't even necessarily have to be limited to mathematical content. I mean, it'd be interesting to get them to reflect on a conversation around their own pedagogy with a colleague. Mm-hmm. That's something that this that is currently being expanded to, but not my paper.
Right. But you are doing some future work, so what are some next steps that you're taking with this work?
I'm currently working on something with Amy Momolo on sort of getting it more effective things using similar kinds of scripting. And that's about all the detail I'm willing to give on that. There's something currently under review and a couple more articles that are slowly in the works that I'll have much more time for now that I've done my postdoc and have time for side projects. This coming year, I'm hoping to use this method with some actual calculus students and hopefully show that it's applicable to more than just people involved in strictly people that are on a teaching track.
Right.
So hopefully there'll be some interesting articles for people to read and interesting articles for me to write.
And you, in the JMB article, you also mentioned that your analysis focused on the mathematical content that you can kind of glean from these proof scripts, but also you could do a whole second analysis focusing on the implications for the pedagogy that's going on. Like, you have a teacher character interacting with a student character, and you could do a whole pass to analyze that data about what's the nature of that teacher-student relationship and the instruction that's going on.
Absolutely. The data is still fairly wide open for that. I'm getting more and more busy with more and more projects. If anyone's interested in looking at the data from that perspective, I'm happy to hand it to them.
And the methodology allows for both.
The methodology allows for both, and they do feed off of each other. I'm primarily interested in sort of undergraduate math ed, and so my interests lie more in terms of content understanding, but this evolved out of something that was aimed toward pedagogy and understanding and envisioning pedagogy. I'm very excited with how it turned out. So,
my guest is Dov Zazkis, and I always have one final question that I ask my guests, so you probably know this is coming. So you're from a math education lineage, and you're now here, getting off to a nice start to your math ed career. But what if you weren't in math education? What if you could have a whole alternate reality for yourself? What do you see yourself doing?
I would love to be a paid musician. That would be lovely. And if I could do some kind of driver training, be an instructor for that, I think that'd be a wonderful job as well, although mildly more dangerous than musicianship.
Hey, driver instructor during the day, and then
musician at night.
Yeah, musician at night. And what do you play? Is it an instrument, or do you sing? Or
I do. I started off as a guitarist. I played bass in a couple bands in high school, and I recently acquired a drum set, so I try and know a little bit about everything. Mm-hmm. And kind of my general philosophy on life to have my hands in a lot of
know how it all fits together.
Know how it all fits together. Know what every instrument's role is. Yeah,
and what kind of genre of music are you most kind of into?
Currently, kind of heavy modern blues, but we'll see. I often get bored with one genre and move to the next.
Yeah, and if you're making a career out of it, it'd be wherever the money was, probably.
There is that selfish intent, yes. Yeah. I don't think I'm going to be writing songs for Britney Spears anytime soon.
Well, Dov, thanks so much for taking the time here to talk about your article.
It was a pleasure talking about it. Thanks for having me.
Thank you for listening to this episode of the Math Ed Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.